Okay, so in this video, we're going to go over how to calculate either the concentration of hydrogen ions or the concentration of hydroxide ions. So, for example, maybe your question is, what is the hydrogen ion concentration of an aqueous HCl solution that has a pH of 3.0. So again, we're going to use our equation pH equals negative the log of the hydrogen ion concentration. But here, instead of solving for pH based on the concentration, we're going to solve for concentration based on the pH. So plug in what you're given, 3.0 equals negative the log of hydrogen ion concentration. Okay, first thing I'm going to do is get rid of the negative, so divide both sides by -1. So -3 equals the log of hydrogen ion concentrations. Now, what log means is, what do you have to raise 10 to the power of to get this? So the inverse of this is going to look like this. So 10 to the -3.0 power equals the concentration of hydrogen ions. So now what you'll do is you'll plug this into your calculator, right? So you got your calculator and you do, let's see. I'm going back to the internet. All right, if you do 10 raised to -3rd power, which again I could do just by moving the decimal, you're going to get 0.001 molar is what goes with our concentration brackets here. So molar equals the concentration of hydrogen ion of ions. So that would be your answer for this first one. All right, what if they ask, right, so same question. Let's say this is part A, part B. What if they ask, what is the hydroxide ion concentration of the same solution? So here, right, if we're looking for the hydroxide ion concentration, we would need to use POH equals negative the log of hydroxide ion concentrations. And you might be thinking, well, gosh darn, I don't know the POH. That wasn't given to me. pH was given to me. But remember, we also have this equation, pH plus POH equals 14. So we can convert always between the two. So if we know the pH is 3 plus POH equals 14, then we can solve for POH. POH, you would subtract 3 from both sides, equals 11. Now I can plug this in over here. So if my POH is 11, equals negative log of hydroxide ion concentration. All right, I'm going to get rid of my negative, divide both sides by -1, so -11 equals the log of hydroxide ion concentration. So again, 10 raised to the -11th equals my hydroxide ion concentration. So I'll plug that into my calculator, and you'll get a very, 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 very small number, right? 10 raised to the -11. You should just move that decimal to the left 11 times. So 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right, equals the hydroxide ion concentration. If you wanted to leave this in scientific notation, that would be fine, right? You could write it as 1 times 10 to the -11 molar equals my hydroxide ion concentration. All right, so based off these results, right, C, which ion, hydrogen ions or hydroxide ion is in greater concentration? Which one do I have more of in the solution? This is a bigger number than this, so my answer here would be the hydrogen ions are in greater concentration, which means D is this solution acidic or basic? And your answer would be acidic, which you might have been able to tell even based off my initial pH, right? The pH is 3. Anything with a pH less than 7 is going to be considered acidic. All right, one more problem for you. Let's do my pen. Number 7, it says find the concentration of hydrogen ions and the concentration of hydroxide ions of a solution with a pH of 3.494. All right, so again, we'll plug in what we're given and solve for what we're not given. So they gave me pH. I know pH is equal to negative the log of hydrogen ion concentration. All right, so pH 3.494 equals a negative log of hydrogen ion concentration. Get rid of that negative 494 by dividing both sides by a negative equals the log of hydrogen ion concentration. To get rid of the log, I'm going to do 10 raised to the negative 3.494 equals my concentration of hydrogen ions. All right, so go to your calculator or the internet, type in 10 raised to the negative 3.494. And for your answer, you should get 0.0003206 molar equals my hydrogen ion concentration. All right, to find hydroxide ion concentration, I'm going to have to use my POH equation. POH equals negative log of hydroxide ions. But first, I'll have to convert from pH to POH. So pH plus POH equals 14. They gave me the pH was 3.494. So subtract 3.494 from both sides. 14 minus 3.494. I got the POH to be 10.506. So I'll plug that in up here. 10.506 equals negative the log of hydroxide ion concentration. Move that negative by dividing both sides by negative. And then to do the inverse of log, it's 10 raised to the negative 10.506 equals my hydroxide ion concentration. Plug that into your calculator or your internet search bar. 10 raised to the negative 10.506. And so for my answer here, it'll be a really small number. I'm going to keep it in scientific notation, 3.11. Trying to think about how many sig figs we had to start with. 4 times 10 to the negative 11 molar equals my hydroxide ion concentration. So again, we knew this even from the beginning, but my concentration of hydrogen ions is way higher than my concentration of hydroxide ions, so this solution would also be considered acidic.